Okay, hi. Um, are there any questions about administrative issues or anything like that? Um, um, I do want to mention that for Tuesday, there's a fair amount of reading, so just be warned about that. It's uh, three different responses to Popper. Um, and and the other thing I should mention before I start talking about the reading is when I'm going to get your midterm assignment back. So uh, my my hope had been I have a I have a schedule. I'll be able to finish grading them all and get them back by a week from today. So that would be 2 weeks from when you handed them in. I'm slipping behind that schedule for various reasons, so I can't promise that. But that's anyway. That that's my hope. If um, Okay. Are there any questions about that or anything else like that? All right. So on to the reading, which is from chapter 10 of the Logic of Scientific Discovery. And yeah, most of what we skipped in between chapter 5 and chapter 10, and also the parts of chapter 10 we're skipping, are kind of technical stuff about probability and issues related to that. Um, um, and um, A lot of it is things that turned out later not to work. It's similar to what I said about the Aufbau, so it's less interesting than you might think. It's things that he tried to fix later on. But there is one important point about probability of theories, which I'll mention when it comes up. Um, I mean, there's probably more than just that one important point, but anyway, that's the one I'm going to mention when it comes up. Um, okay, so the issue in this reading, more or less, is how or why or in what sense does science make progress? Um, and I mean, this is sort of the key issue, both for comparing Popper's view to the inductivist or justificationist view that he's arguing against, um, but also for understanding the issues between Popper and Kuhn that we're going to see coming up, right? So after that one reading, which is these more like immediate responses to Popper, the rest of the course is going to be Kuhn's structure of scientific revolutions, which is um, actually, according to Kuhn, he hadn't read this book when he wrote Structure of Scientific Revolutions, and his knowledge of Popper was kind of limited. It was based on some lectures he heard or something, um, but nevertheless, I think you know, and I hope to make this clear that it's Popper's view of science, broadly speaking, that the structure of scientific revolutions is an attack on. Um, Okay. So anyway, so that's why this is a key issue. I mean, I guess it's obviously even going back to the things I said at the beginning of the course. It's in some sense the issue that philosophy of science exists because of, right? I mean, the question is why is modern science making progress in a way that um, traditional philosophical investigation did not. Um, so, um, so that's the main issue, but I guess it's within the context of maybe an even deeper or more important issue, which is, what is science good for? Like, why should we do it? Um, or in other words, I guess you might say, what is it making progress towards? um, so, and we expect that the answer to this question, according to Popper, ought to have something to do with his solution to the demarcation problem, right? That is, it ought to have something to do with falsifiability. Otherwise, his demarcation criterion, which remember is a proposed convention as to what we should call science. Um, otherwise, if the answer to these questions doesn't have anything to do with falsifiability, or that is, if falsifiability doesn't supply a distinctive answer to these questions, then it will look like the rules of the game that he's proposing are rules of a game that's not worth playing. Um, okay, and so um, the problem is especially acute for Popper because it looks like, so, if I were to write, like, here's the two questions I mentioned. Why does science make progress? And what's the point of doing science? Um, um, it appears as if the verificationist or inductivist or justificationist view, and I'm not going to go over what all those things mean again, but they all go together for Popper, and they're all, the package of them together is what he's rejecting, right? It seems like that whole position has a good answer to these questions, right? So the answer to those questions, according to the inductivist, is, first of all, in terms of the answer to this question, well, scientists accumulate empirical facts, right? They build up more and more observations as time goes on. And the more facts we have about the more different things, um, number one, more facts, that is, more observations. So more facts means we have better justified theories, right? Um, because again, inductivists think that by collecting singular observational facts, we're justifying our universal theories. So our theories become more justified. Um, or I think you could also say, our theories become more universal. Or maybe you could put it this way, at a given level of universality, the theory becomes better justified. For a given level of justification, it becomes more universal. Um, right? And, again, because you're learning more and more about more and more different things. So, you know, the special rules that you've gathered, you get to know better and better, and you start to know more general rules. Um, now, um, this is maybe kind of a digression, but it's important, and it's going to come up when we discuss Popper's alternative as well. Like, what do we exactly mean by more general or more universal rules? I mean, after all, if you have a statement that says, for all k something, that's as universal as it gets. It's for all k, right? And remember, if k stands for spatiotemporal um, position, then this means everywhere and always. How can it be more universal than that? I mean, in some contexts, the answer is, well, there's different kinds of universality, numerical versus strict universality we talked about before, or restricted universality, like for all k that's a member of so and so is what you really mean, um, versus for all k that's a member of some bigger um, spatiotemporal restriction or other kind of restriction. Um, but uh, but learning more and more facts is not going to get you that kind of universality. Um, so um, so I think the time when you can say that something is more universal is when you already have a theory. And then we can say a new theory is more universal than the old theory when it implies the old theory and more than the old theory. Um, or at least when it implies the old theory insofar as the old theory was successful and more stuff, right? And I'm adding that because, as Popper says, um, both when he gives his exposition of the inductivist position and when he talks about his own position, um, you know, many times the old theory ends up being a limiting case in the new theory, meaning that the old theory is true only in specific circumstances. So the old theory was a hasty generalization or something like that, right? I mean, the example of this that people always have in mind is that, especially the transition from Newtonian mechanics to relativity, right? Where, you know, the new theory explains why it seemed like the old theory was true, because as long as things don't go too fast relative to each other and gravitational fields are not that strong, then, um, Newtonian mechanics will predict observations just as well as relativity theory does. Um, so anyway, that's the theory is more universal than the old theory because it explains the success of the old theory and also other stuff. Um, and sometimes that takes the form of I have a bunch of scattered old theories, and the new theory explains all of them and more stuff. Um, um, So, and remember, I argued that that's what Popper means, generally speaking, by higher levels of universality, right? This was way back when, I guess, when I talked about the very first reading from Popper, and where he says that a scientific theory is a system of statements. And I claimed that that system part is important, that a scientific theory is not just like a bag of statements, but that it has fundamental statements from which other ones are deduced, and then other ones are deduced from those, and so forth, right? And that the ones at the top that everything is deduced from, the axioms, are the ones that Popper calls the most universal. They're not more universal because they apply to more things, but they're more universal because um, the other parts of the system can all be deduced from them. Okay, so right, so getting back to the inductivist, right? So it seems like in terms of why does science make progress, they have a good explanation. Science has to make progress because we're always getting more and more data, and the more we get, um, the better the theories that will be justified. I mean, um, unless something catastrophic happens, right? Unless starting tomorrow, all our data are different from all they were, all the old data were, right? So that we can't even think of anything that was any theory that was justified by the old theory that's also, now justified by the new theory. But um, if you believe in induction, then by definition, those catastrophes are very unlikely. They're improbable, right? So to reduce the claim just slightly, according to inductivists, if science is done right, it will very probably make progress. And then, in terms of why should you do it, well, it seems like now there's a good answer to that too. Um, since as we make this progress, we're getting theories that are more and more probably true. Um, we shouldn't be surprised to find that they're useful. Right? So, I mean, of course, we know that scientific theories are often useful, but the inductivist can explain why they're useful. In this sense of explanation, can say, well, don't consider it a miracle that they're useful. Um, they're probably true. So if something's probably true, then it's, probably makes true predictions that you can rely on. So, if you rely on theories that are probably true and are getting more and more probably true all the time, then um, insofar as what you need for your life is to be able to make true predictions, to design and plan and so forth, um, your life is getting better and better. Right? So why do science? Because it's, for the good of humanity. Um, so, I mean, Popper makes this whole case pretty strongly, and I just want to point out where he does that because I know in the past it's often been the case. I mean, this can be. Where's my camera? Oh, there it is. This is a general type of problem that students sometimes have reading philosophical texts. It comes up a lot in the first meditation. I might have mentioned it before in this class, but maybe I should close this while I'm still trying notes away. um, that you know, I think in ordinary life, when we're involved in a dispute, we try to say all things that favor our side and no things that favor the other side. um, so, um, but philosophers, for what reason? I mean, Popper actually is in a good position to explain the reason. But I'm not sure his explanation is right. But anyway, for whatever reason, philosophers, when they make an argument, will tend to say a lot of things that favor the other side and then explain why they're wrong. um, but that can be confusing because if you're not paying careful attention, you'll think that in that passage the philosopher is supporting their side. I mean, why would they be saying it otherwise? So, right. So I just want to point out that starting here on page 249 with "It is quite true," they say, and going basically to the end of this paragraph, um, it's all Popper's opponents speaking. Then Popper himself starts seeking again here. There is something to be said for the above argument, right? So all of that is the inductivist speaking, and um, um, they're basically making at least the beginnings of the argument I just made, right? They're saying, according to us, we can explain why science makes progress and why it's useful. Okay. Um, so all of that sounds good for the inductivist and therefore bad for Popper. Um, but of course, it all depends on this one thing, namely that facts justify theories. Um, that is, that you can collect singular statements that imply that a universal theory is true, or at least make it more probable that it's true. Um, and once again, remember, what Popper has said about this is that about this connection is that first of all, it's not logical. Right? It's not there's no contradiction in all these singular statements being true, but the universal statement being false. Again, like if the universal statement is made in the spirit of strict universality, that has to be true. Um, all these finite number of individual instances could all be true, but the universal statement that says always, everywhere, something could still be false. So this is not a logical connection. But then Popper says, and so, I mean, that's why we need a principle of induction. If this were a logical connection, then you would get from the facts to the truth of the theory or the probability of the theory. But remember, what Popper said about that was that, um, in that case, you're still saying that some theory is true and not just probable, namely the theory that some theory is probable. Right? That is, you're still trying to gather evidence for a universal statement. So, right? So if individual facts ever implied that some universal statement was true, then um, we wouldn't need a principle of induction. It would just be deduction, right? But since the connection's not logical, we need some other principle. And the principle, Popper says, well, it's not empirical. Why can't it be an empirical connection between these things? Well, it can't be empirical either in the inductivist sense or in Popper's sense. It can't be empirical in the inductivist sense because it would lead to infinite regress, right? And this is the argument that Popper already made before in chapter 1, that, if I say, well, you should believe that induction works because it's always worked so far. That's what it would mean if the principle of induction were empirical, according to an inductivist. Then you would need a principle of induction to justify that, so you would need another principle of induction. I guess, it's either infinite regress or circular, depending on how you look at it. But in any case, your empirical justification can't work because empirical justification always relies on a principle of induction. That's exactly what we're talking about here, empirical justification. But it also can't be empirical in Popper's sense, and this is an argument Popper makes in this chapter. When I assert the principle of induction, that, it's probable that the future will resemble the past. It's probable that the unexamined instances will resemble the examined instances, whatever, something like that. I can't mean it in a spirit of falsifiability. Right? Remember that ultimately the question of whether a theory is falsifiable is not just a logical question about what it implies, but it's a methodological question about how I'm going to use it. And so, that is, you might think that principle of induction can be falsified, right? Like, I make a bunch of observations, I take them to justify some theory, but then I find I make more observations and I think the theory is false. And now I've not only falsified the theory, but I've falsified the principle of induction because induction didn't work, right? But Popper says, obviously, so if you meant the principle of induction that way, it would be an empirical theory by Popper's criterion. But Popper says, obviously, you don't mean it that way because then that theory has been falsified over and over again. Every time we had to discard some theory in favor of a different one, the principle of induction has been falsified in that sense. So that's not how it's meant by the inductivists. The inductivists can't mean it as a falsifiable hypothesis. They must mean it as something we're going to continue to believe no matter what, so that when we see that our first guess was wrong, we're going to say, well, okay, it was probably right, but it turned out to be wrong. But this new theory now is probably right. That's how we're going to react to that situation, because we're not going to allow the principle of induction itself to be falsified. So it's not empirical, and therefore the principle of induction must be metaphysical. And if it's metaphysical, then either it's synthetic a priori, which Popper says again in this chapter, although again without any giving an argument. I think he doesn't feel a need to argue because this is something that he and the logical positivists agree about. Right? He says, synthetic a priori, but that doesn't work, basically. So if there's no synthetic a priori, what kind of reason could we have to adopt this kind of non-empirical metaphysical principle? Well, it must be methodological. And to that, Popper's response is, but inductivism isn't a good methodology. It leads to dogmatism because it consists in always trying to defend your theory and show how right you were. Okay, so Popper says, so we can't or shouldn't make this connection. We can't make it based on logic or empirical evidence or synthetic a priori truth. And we shouldn't make it methodologically speaking. We shouldn't think we're in the business of finding facts that agree with our theories. Um, so, therefore, although the inductivist seems to have a good answer to this question, I mean, this is still, in a sense, a point in the inductivist's favor. The inductivist can say, well, okay, I understand you're criticizing this connection here, but I just want to point out that if you accepted this connection somehow, then we would have a really good answer to these questions. So maybe we should look at it again, right? But in any case, Popper says, no, we can't or shouldn't make this connection, and therefore what looked like a good answer to these questions was not a good answer. Okay. Um, So another way to put this would be to say that the inductivist answer would make sense, except that there's no solution to the problem of induction. And this, once again, was what Popper um, before called Hume's problem. Um, we've seen three different versions of Hume in this course, if you pay attention, right? There was Goodman's Hume, Quine's Hume, and Popper's Hume. They don't really agree with each other. But I don't have time to talk about Hume interpretation now, so I'll just point that out to your attention. But in any case, right, so there's no solution to the problem of induction. Um, and and the question is, what is Popper going to offer as an alternative? And in what sense is Popper's alternative going to solve the problem of induction? And in what sense is it going to reject the problem of induction, basically? Now, I mean, you might think, based on everything you've read so far in the book, or actually, you might think, based on everything he says up to now in the book as it was originally published, that the answer is, well, since I'm not an inductivist, I'm just rejecting the problem of induction. There is no problem in that area because, um, or well, it's what you might call a negative solution to the problem of induction. That actually is Hume's terminology, which Popper picks up on, but he picks up on it in this addendum to chapter 10, which was added later. Actually, I'm not gonna put that on the document viewer, but right at the very end of the chapter on page 281 to 282, there's an addendum with a bunch of different points, and the though it's not doesn't have a title, the subject matter of that addendum is basically, okay, so how do things stand now with the principle of induction? Now that I've said everything I'm going to say. So, so what Popper actually says there in that addendum, and I think it's an accurate reflection of what happens in the original text. Um, but it's just summing it up in a useful way. Um, Popper says, well, there's actually um, more than one problem of induction. There's a logical or epistemological problem. And that one actually falls into two different parts. One part is how can we justify our theories based on our observations? But the other part is how can we justifiably prefer a theory? Right? So justifying the theory is a matter of showing that the theory is true or probably true. Preferring a theory is not necessarily a matter of that. It depends why you prefer theories, right? But but in any case, but there's in both parts there's a question of rationality, but it's rationality about something different, right? And here we're asking why is it rational to start believing the theory or to believe it more and more. Here we're just asking why is it rational to keep working with this theory instead of some other theory. Um, so it's Popper says in the addendum, this is the one I'm giving a negative answer to. We cannot justify our theories using observations. As I pointed out, this is the whole thesis of the book, right? Or I mean, at least half of it, I guess, the negative part of the book's thesis. Um, uh, but as I pointed out before, when people who like Popper often disregard or play down this part, right? So they're like, oh yeah, to be scientific, a theory has to be falsifiable. But then when you say, oh yeah, and you agree that whenever we make observations, they don't make our theories even probably, more likely to be true or anything like that. And they'll say, well, no, I mean, he overstated that. Of course, they make it, well, make it probable, or something like that, right? But for Popper, this is the whole point. There is no answer to this problem of induction. But he says that he can answer this one. He can give a positive answer to this one. And moreover, there's three other problems here. Now, um, um, I'm doing something potentially confusing here. I'm numbering these four problems. In the addendum, there's five numbered points, but actually, my number 1, 2, 3 doesn't correspond to those numbers 1 through 5 because one of those points is not doesn't introduce a new problem. So, but anyway, I'm numbering 1 through 4. There's so right. So there's these four different versions of the problem of induction. This one I just talked about. This one is, Popper says, is the problem, are there real regularities in nature? That's a metaphysical problem. So, I mean, it's both a metaphysical problem in the sense that you would expect that to be discussed by someone who says they work on metaphysics. um, uh, uh, right? You'd expect it to be discussed in a book or a chapter of a book where the title was metaphysics. But it's also a metaphysical problem in Popper's technical sense that although it's not nonsense or pseudoscience, it's not empirical science because the answers aren't falsifiable, right? I mean, because the real regularities in nature might be much too complicated for us to have noticed yet, for example, right? So no matter how many chaotic observations we collect, it doesn't show that there aren't real regularities in nature. And then on the other hand, of course, how much evidence we've accumulated so far of a regularity. The whole point here was that it doesn't guarantee that there is a regularity. It doesn't justify the universal statement. So this is a metaphysical question. And Popper is going to give an answer to this question. It's most explicit in the addendum, but I think he's trying to more or less faithfully interpret what he really meant when he wrote the book. And he says, my answer is yes, there are real regularities in nature. Okay, then there's a pragmatic question. Why is it rational to rely on our accepted theories? I guess, or is it, and why is it? So, Popper says, I'm going to give a positive answer to that, too. It is rational to rely on these theories. And finally, Popper says there's a psychological question, which is, why do we believe that our best scientific theories are true, or at least, of course, we don't really believe that they're true, but we believe that they're similar to the truth, right? This is the question of verisimilitude, that is similarity to the truth. So we believe we're on the right track, at least, right? So, and the question is why? Why do we believe that? And Popper is going to say, um, well, we do believe that. It's not rational to believe that. But that's okay because it's not rational to believe things. All right, um, so that's the way he sets this up. I mean, he sets it up in the addendum, or I mean, that's the summary of where he's going. That's based on what he himself says in the addendum to the chapter. Let me put it that way. But so it looks like it's going to be hard for Popper to do what I've just summarized, right? Because it looks like having given up on this, um, so we're saying that our best scientific theories are not justified, even a little bit, right? Not just that they're not, and this is really important not to misunderstand what Popper is saying. So I'm going to say it again, even though I already emphasized it before today. He's not just saying that you can't be sure that your universal statement is true. Because, new evidence could come in and cause you to abandon it. Everyone knows that. Inductivists, the people he's talking about, know that. What he's saying is, it's not even likely to be true. You have no justification for it. Your evidence doesn't justify it, even a little bit. Right, so where do our theories come from then? And the answer is we guess. They're guesses. And we're not trying to defend them or justify them because that's impossible. On the contrary, we're trying to falsify them. Now, at this point, the inductivist is going to say, and, by the way, you're likely to succeed in falsifying them, because they're just guesses. you're, it's kind of an easy task you set yourself. Just guess that something is true and then try to falsify it. Yeah, you're probably going to succeed. So, right, another way to put that, though, would be to say, Inductivist saying, well, okay, or, I guess, or Popper himself can ask it this way. Okay, we've given up this, when we prefer one guess over another, it's not because one is a better justified guess than the other. It seems like whatever our grounds for preference are, they won't have anything to do with truth. And therefore, if ultimately what we want from the theory is for it to be useful, it seems like we aren't whatever reasons we think we have for preferring one theory and the other, they can't be rational. We're not acting rationally. Right? So, that is, even though I put this, as Popper does, under logical, epistemological, this is really like the practical side of logic or epistemology, the question of whether the rules of this game of science are rules of a good game, that it's rational to play. And it's rational to play a game if, you're going to get something out of playing it. And you could say, well, it's rational to play lots of games because they're kind of fun, even though we don't get anything further out of them when we're done playing. But if that's all that science is, then and I think this is at the basis of a lot of what's going on here, is that this is the very time when science has started to ask for more and more resources. Right? Like, this is the very time when big science is beginning to take off. That if that's all science is, if it's just scientists entertaining themselves by playing some game, then we shouldn't fund it, obviously. Maybe if it's a fun game for spectators, but it's not. Maybe if it's a fun game for spectators, they could sell tickets, right? But it's not a fun game for spectators. It's on the contrary, what scientists actually do is mostly incomprehensible to non-specialists. And again, this is the period where that's becoming more and more true, right? Where even scientists themselves can't follow what's happening in other fields. Couldn't pick up a paper written in some other specialty and understand it, right? So, what did someone say in the in the defund the physics department? Right. Well, I mean, um, so some sciences where the usefulness seems hard to see or even maybe absent by definition, like most parts of astrophysics, um, their funding has gone down um, since the end of the Cold War. When so, I mean, this is also like, why is this the time when big science is taking off? Because of the way science seemed to pay off in World War II. Um, that's probably, I mean, that's oversimplified, but it's something that both Popper and his critics, often have in mind. I think I know at least one place where Popper mentions this, that a certain type of science has taken off, presumably because of military spending, right? So, right. So, but with the end of as long as the Cold War was going on, like science, money was just flowing into the physical sciences without too much consideration. But once um, that stopped, then people started saying, well, look, this science, astrophysics, it's not going to have any useful applications. It's by definition about things that are too far away for us to do anything about. All right. Anyway, this is too long. This is important, but it's too much of a digression. I'm wasting time in terms of getting to the end of the proper stuff. So anyway, um, right. So that the point is, this is going to look irrational. The reasons we prefer one theory to another are going to look irrational um, if those reasons don't have something to do with truth. Because if those reasons don't have something to do with truth, then those reasons don't have anything to do with reliability, with usefulness in that sense. Um, And you can see the problem, especially by going back to the first question I asked to begin with: why should you expect science to make progress, right? So, I mean, that's basically where this comes up. Why do we prefer a theory? We have competing theories over and over again, and we keep choosing one over the other. And the question is, why should we expect that to yield theories that are more useful as time goes on? If we can, then that is, if it's rational to prefer theories for this reason, um, or if it's rational to prefer theories according to the rules of our game, in the sense that we're probably, or we're somehow preferring theories that it's going to be better to rely on, then we can say that science is making progress in um, um, a reasonable sense of the term progress. It's going further and further, or maybe going further and further, at least. It's not irrational to expect it to go further and further in a direction where we want things to go for a good reason. All right, so that's what Popper has to explain in terms of solving these two problems. Um, these two problems are, also kind of go together and are a little bit separate from these two problems, but in the end, they're connected because it all comes back to how is what we're doing related to truth, basically. Um, so, how are the beliefs we're building up um, connected to the way the world really is? Um, okay, are there questions about this so far? Someone said big science, more like big DARPA. Well, it's not, there are other, right, like biology has become very big. And even, yeah, well, anyway, I know it's not all funded by DARPA. Physics is, a lot of it's funded by the NSF. Some of it's funded by the Department of Energy. But in any case, that's why I said that answer in terms of military is, I think it's important, and it's, it's not something original. A lot of people have pointed to this from different viewpoints, but that it's historically important that World War II is a kind of turning point in the history of science. But um, yeah, anyway, I shouldn't say more about that again now. All right, so first of all, um, Popper does. We need big philosophy of science. The NSF does sometimes fund philosophy of science too, which is one of the few sources of grant money in philosophy. Um, um, but it's also true that in Europe, where there's more funding for the humanities, I'm going to regret talking about this just because I'm going to run out of time at the end. But this is so important to know. Like in Europe, where there's more funding for the humanities, philosophers do spend a lot of time applying for grants, and the grant process is modeled on the process in the physical sciences. So people try to come up with projects that look like big scientific projects where you can hire a lot of investigators and so forth, right? So there's like a PI, and you can hire a lot of, grad students and researchers to be part of your team. And, this favors either proposals that are kind of bullshitty, like, oh yeah, we're all working on this thing and we're working on it together, but it's really just everyone doing their research and taking money out of the grant, or which is risky, obviously, or it favors people doing things under the name of philosophy that aren't necessarily what you would otherwise want to do, but that fit this model. So, like, um, we're going to digitize a certain corpus of, manuscripts, we're going to statistically analyze the contents of philosophy journals, or, things like that, which could be useful, but, anyway. Um, so, what Sean said, we need big philosophy of science, is actually, like a lot of jokes, is kind of painfully close to certain truths, I think. But anyway, so let me stop that digression and go back to Popper. So first of all, Popper agrees that science does make progress um, in um, something like the way the inductivists describe it as making progress. Um, so, um, uh, if I could turn back to the same page I was showing you, it's not 250. I was showing you before. Um, right, so this again, and this is something I summarized, myself before, but this is part of the inductivist description of how progress happens in science. What happens is only that the new experiments decide against an old theory. The old theory, even when it is superseded, often retains its validity as a kind of limiting case of the new theory. It still applies, at least with a high degree of approximation, in those cases in which it was successful before. So this is why, um, rather than um, rather than just getting one new theory after another, which would mean no progress. Um, right? This theory, is it true? No, false. Okay, this theory, is it true? No, false, right? There'd be no progress there. The inductivist can explain why instead the following thing seems to happen in science. We start with a theory. It has a lot of evidence to support it, so it's probably true. Okay, it turns out it wasn't true, but that evidence is still there. So what was true? Well, probably something like this theory, something that agrees with it in the old cases, but then makes new predictions in other cases or whatever. And that's exactly how that inductive direction progress that the inductivists um, that seems to actually happen in the history of science can be explained by the inductivist. Um, so Popper says the next thing he says, as I pointed out, is, oops, um, there is something to be said for the above argument, but it does not affect my thesis. What is to be said for it? Well, in part, like what it actually goes on to say in that um, paragraph there is in part what can be said for it is that as a metaphysical article of belief, or I mean, yeah, so it connects both of these really. As a metaphysical article of belief or faith, you should always know that belief and faith are the same word in German. Right? So it's always a question. Oops, it's not really. It's always a question when you translate Glaube whether you should translate it as belief or faith, and it kind of depends on the tone of the sentence or something like that. So anyway, but I think that faith was correctly chosen as the translation here. It's an article of metaphysical faith that there are real regularities in nature. Um, yeah, in some sense, that's what explains the success of science. But it's not an empirical explanation. It doesn't make new predictions that we could try to falsify. Um, but um, but uh, but there's also something to be said for it in the sense that Popper says, yes, science does, for good methodological reasons, tend to progress in this direction, in this way. So, what are the reasons? And I don't know where to write this down on this page, on this board. I'll just write it here at the bottom, I guess. Okay. I haven't moved the board, so that's invisible. Popper says, well, there is a kind of quasi-induction that happens in science. Now, of course, whenever someone says something like that, you have to be on your guard, like, well, is he actually giving away the case, right? By admitting, well, there's something like induction. Yeah, only it's not induction. Um, so, what generates this quasi-induction is that although theories don't become more probable, or and we have no logical or empirical reason, at least, to believe that they're becoming more similar to the truth, um, they do become better corroborated. The theories become better corroborated as time goes on. What does corroborated mean? Well, Popper says in a footnote there that he chose corroboration as the translation of the German word he uses here, which is beurteilen. Um, it's like a kind of, it comes from urteil, which means judgment, but a kind of like estimation of the worth of the theory or something like that. He chose corroboration because he thought it was neutral between what he thinks theories get and what the inductivists think they get. Um, uh, anyway, be that as it may, I mean, it's basically a technical term for Popper, and you just have to figure out what he means by it. So, a theory is corroborated when, um, well, first of all, it's unfalsified. But that's not enough because, I mean, uh, infinitely many theories are unfalsified. Um, right? There's only a finite number of observations, so it's easy to come up with a theory that doesn't. Easy to come up with a theory that doesn't contradict any of those finite number of observations. Um, I mean, there is some question in this area that some people raise. Is it really true that it's possible to come up with a theory that we could actually understand? It doesn't mention every single empirical observation that's ever been made, whatever. But in any case, logically speaking, the situation is that there's infinitely many unfalsified theories. It's not even enough to say that. So that's one reason why that wouldn't be a good definition of corroborated, but also that doesn't admit of degrees, right? I mean, all theories that haven't been falsified have not been falsified to the exact same extent. That is, they haven't been falsified at all. So, um, so you have to, first of all, you have to add something like, um, 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 you can use the theory to derive a prediction which has not been falsified. Um, right? So, I mean, um, um, that doesn't really, no, I'm confused here. Right. I guess. Okay. No, I'm saying it a little bit wrong. Right. So, you might think it would help to say, well, we have to have used the theory to derive predictions which came out true, and it's not falsified for that reason. Right. So that rules out most of those infinite uh, theories that are getting in the way, because most of them, although they don't contradict the observations we made, they don't predict them either. Right? So, I mean, we're narrowing it down somewhat. And moreover, we're getting something that could be a matter of degree as well, because, you know, some theories predict more of the things we've actually seen than others do. Um, but uh, so that would give us a means for deciding between theories, right? We can say, well, this one, they they both haven't been falsified. Moreover, they both have made some true predictions, but this one has made more true predictions than this. You can't, I hate you can't see my hands when I make hand gestures. All right, whatever. This one has made more true predictions than this one, so that's why we're going to prefer it. Um, uh, but Popper rejects that, and roughly speaking, the reason he rejects that, or says it's not enough anyway, is that not all predictions are equal. Not all predictions are equally bold or surprising. So what we really want, and these are the parts of the definition of corroboration. Now, I mean, Popper doesn't give a um, mathematical definition of degree of corroboration here. He does, in some other places, make some tries at doing that. Um, and so we'll see part of the issue between him and Putnam is whether uh, Popper is committed to being able to kind of automate this process by giving a mathematical definition of corroboration. But in any case, he doesn't try to do anything like that here. But he does say, this is what I mean by better corroborated. Um, a theory is better corroborated than another theory if, number one, and these are kind of like two independent factors, I think. Well, there's been another comment here. Okay, that's circular. I'm sorry. So I think these are two kind of independent factors. One is that a theory is better corroborated than another theory if it's um, simpler. So that, yeah, actually, Okay, no, I haven't built up to this part, but I'm going to say it anyway because it's important. So it's simpler, which means, according to Popper, I mean, this is a notorious problem. Like, it seems important about scientific theories that we want a simple theory, but then when you try to define what simple means, it turns out to be really difficult. Um, you know, uh, it doesn't mean you can write it down in a really short way, because you can always do that by defining the right terms. So, like, all emeralds are grue is a simple theory by that criterion because it only has one predicate. So it's just as simple as all emeralds are green. All right. Well, anyway, be that as it may, Popper thinks, and I'm not sure if he ever was able to make this successful or not, but he thinks and continues working on throughout his life. He thinks that you can give a definite um, um, definition of what it is for a theory to be simple, and he says what it means for a simple to be theory to be simple is for it to be more falsifiable. So a theory is simpler than another theory if um, it rules out more. Or, in other words, as he also puts it in a kind of paradoxical or counterintuitive way, if it's less probable. Now, why you should use the term simple for that, I feel like I don't have time to go into, but um, um, I mean, I think there is a Popper does have a good case that when we say that a scientific theory is simple, what we really mean is that um, not just that it doesn't say very much, or not just that there isn't very much to it, but that there's a lot to it per unit it, so to speak. In other words, that it says really a lot for the theory that it is. In other words, that it makes more types of predictions and therefore it's more falsifiable, something like that. All right. Anyway, so that's one factor, and then the other factor is that not just the number of true predictions it's made, but the number of sincere and severe tests that it's passed. Um, so we're not interested in just like checking the theory against everything that's ever been observed. We're interested in observations that have been made or that will be made, but that any case that are really surprising. Um, Surprising based on our existing theories, I guess. Um, um, it doesn't matter that much, I guess, why we find them surprising. That is the psychological side to things. The point is, the methodological point that we should remember that we're trying to falsify the theory. So we're going out and looking for stuff that we're like, we're not going and looking for stuff where we're like, oh, that's probably true. Let's check that it's true. We're going out and looking for stuff where we're like, what? Really? And then we check if it's true. And again, what matters, the reason that psychological thing, which may or may not have any rational basis, is important is because it reflects our practical attitude. This is like, I think I'm reading a lot into to Popper here, but I believe I'm reading the right thing into Popper here. I think this is what he means, that it's important. That's why he says sincerely, right? That's obviously a matter of our psychological state in one way of understanding it. Are we really trying to falsify the theory or not? Um, um, in some so in some sense, it's an empirical matter of our psychological state. Are these people going and subjecting to their theory to tests that they, for whatever reason, don't necessarily expect it to pass? Um, but that empirical or psychological state is important because in Kantian terminology, it's a sign of what we've adopted as the supreme maxim of our will. It's a sign of the attitude we've taken up, what game we're playing. Right. So those are the two factors that corroboration depends on. And Popper says if we prefer theories that are better corroborated in that sense, um, then we're typically in a case where we're faced with a choice of retaining our old theory or adopting a new theory, right? That is, in the case where scientific progress may happen, um, we're going to prefer the new theory if the new theory, um, um, first of all, passes more severe tests than the old theory did. And second of all, um, or I gotta say the other way around. First of all, is simpler. That is more falsifiable. That is more capable of severe testing than the old theory was. And second of all, um, actually has passed more severe tests than the old theory. So that means that the new theory that we're going to be preferring is going to be one that, um, number one, uh, um, on the whole, passes the tests that the old theory passed. So it explains the things that the old theory explained. And it also says new things that the old theory didn't say. Um, so it's going to pass tests that the old theory couldn't pass, but it's also going to be a ground for proposing new tests um, that weren't relevant to the old theory one way or another. So it's going to explain the old theory, at least as a limiting case, right? It's going to explain why the old theory was successful in the cases where it was successful, and it's going to say more stuff. So we're going to end up with theories at higher levels of universality that, and again, higher level of universality means that we're ending up with theories that explain the old theories, at least as a limiting case, and say more that the old theory didn't say. Um, so, so to summarize all of this, Popper says, if we prefer the theories that are better corroborated in this sense, if that's what scientists are doing, then we expect the kind of progress that we actually see in science. So that is, my methodology accounts for what scientists actually do, for what we actually see in the history of science, as well as the inductivist can. And again, that's important to him because, although, you know, we could call science what he calls science, even though it turns out that the people we used to call scientists are not doing that. Um, uh, uh, it would be bad to do that if what he calls science doesn't. The whole reason we're in this philosophy of science business, I was going to emphasize once again, is that modern science seems really successful and philosophers are trying to understand that. right? So if in the end all Popper can say is, here's a good game you should play, um, but it's not what the scientists were actually doing, um, then uh, um, and it shouldn't be expected to make the kind of progress that the scientists were actually making, even if they did switch to start doing this, then that doesn't solve our main philosophical issue about modern science. Popper does want to solve that. He wants to explain why modern science is so successful, and hopefully in such a way that philosophy can learn something from it about how to be more successful itself. So therefore, it's good that if it's true that preferring theories as better corroborated would yield, if scientists were doing that, would yield the kind of progress that at least um, Popper is agreeing with the inductivists is the kind of progress that science makes. We'll see that in some way Kuhn's whole attack on Popper is based on saying um, that's not the kind of progress that science makes. But all right, so getting back to Popper, now I have only a few minutes left to discuss um, what then can Popper say about these problems of induction? Right? So, I mean, because we've said why uh, preferring theories that are better corroborated would lead to um, theories that explain our old theories and make more predictions. But on the face of it, that still doesn't help with the problem here, which is, you know, okay, but the old theory and the new theory are still just guesses. They aren't justified by those observations that they explain. Right? So the old theory wasn't justified by the tests that it passed. And the new theory isn't justified by its ability to pass those tests and more tests. Neither of them are justified at all, even a little bit. They're guesses, right? So although we can, Popper can explain the history of science in a sense, that is the type of progression in theories that we see, he can't explain why that type of progression would count as progress in the sense of being useful. Um, So, I mean, this briefly is what he has to say about it. Um, so, first of all, he says, as far as this goes, um, no, I was going to say one other thing, but all right, I'll skip that. Okay, so first of all, as far as this goes, um, in preferring theories that are better corroborated, um, being better corroborated is not the same kind of thing as truth at all. Because truth is an absolute and timeless matter, right? If the theory is true, then it's true. Remember that, like, for all k is supposed to mean everywhere and always. That's in the theory, right? So the theory consists of absolutely universal statements. Um, so if it's true, it's always and everywhere true. But corroboration is a property of a theory relative to what tests we've actually carried out, and also how sincere we were about them, right? So it's relative to the time at which we're asking the question, and also relative to the science. I mean, I keep adding these and also things because Popper doesn't mention them here explicitly, but they actually are part of what he has to say. And also, it's relative to the scientific community that's asking it. right? So, um, and what Popper says is, uh, so if you want the theory you prefer to be true or truth-like, to have verisimilitude, then this method and won't isn't rational, and no method is rational, right? Because every method requires you to make the decision, to make a specific community, to make this decision at a specific time, not for everyone to make it always and everywhere. But he says, in the real situation we're in, where we have two theories and we care about truth, but we have no way of guaranteeing a timeless, universal property like truth. If we care about truth and we want to prefer one to the other, then rationally, this is the one we should choose, the one that's better corroborated. I would say more about that, but I'm almost out of time, and I want to say at least a little bit about the other things. So, so, um, so basically, he's saying, are you getting a guarantee that your theory is true? No. Do you want your theory to be true? Yes. Do you believe it might be true? Yes, because you must believe in the metaphysical thesis that there are true regularities in the world. There are real regularities in the world. So you believe it might be true. Um, um, in fact, you have a tendency to believe it is true, psychologically speaking. So what should you do here? You have two theories. They both might be true. You have a tendency to believe that they're both true. Maybe you have more a tendency to believe one is true than the other. Which one should you choose? And Popper says, well, if you're rational, you should choose the one that you can that has been tested most severely and can be tested most severely in the future. And again, this is because if you're rational, what you should be doing in this situation where you don't have access to truth is um, trying to make sure that you won't end up a dogmatist. You're going to believe some theory anyway. You're going to rely on some theory anyway. Make sure you don't get stuck in it. That's the rational thing to do. Okay, I'm sorry. I see there's a question here, but... Oh, okay. Yes. All right. Um, so, um, so that's how the answers to all these things come together. You're going to believe some theory. You must believe that some theory is true. You're going to believe that some theory is true, that some particular theory is true, right? You must believe that some theory or other is true. As Popper says, practically speaking, we couldn't live in the world if we didn't have this metaphysical belief. Psychologically speaking, you are going to believe some specific theory is true. You're going to have that tendency. What's rational to do? It's rational to try to make sure you've picked a theory that you can criticize, that you can test. And then it's rational to rely on that theory. It's risky. Of course it's risky because you don't know if your theory is true. But you know you were going to rely on a theory anyway. It's best to rely on the theory, again, that you won't get stuck with. All right, there's a lot more to say about that, but I'm out of time, so I'm going to end the recording here.